This presentation is for the Stabilis Universal Powerized Demo Station project by Nathan Witt, Fernando Aguilar, William Daniels, Caleb Patel, Connor McCall, and Tyler Thompson, mentored by Dr. Kutitaru, and supported by Hunter Soper, Nathan Sprick, and Aaron McClure at Stabilis. Stabilis has a background in manufacturing damped gas springs as well as electromechanical actuators, typically for automotive use. The Stabilis Powerized product line introduces actuators to use in home applications. Using actuators in a powerized electronic control unit allows the operation of in-home applications such as automatic cabinets, drawers, doors, or windows, among others. To showcase powerized actuator and ECU functionality, the team is tasked with creating a demo system that shows the capabilities of the powerized system. To demonstrate the utility of the system, various control inputs should be implemented. The control requirements of the project include controlling actuators with a mobile device and other wireless inputs, changing ECU parameters and modes through a mobile application, and controlling electronic latches along with the actuators. The physical requirements include demonstrating different application types, supporting the operation of ST35 actuators. The system should be robust, self-encasing, and self-supporting, and should be within the shown footprint and height. Also, an option for manual operation of actuators should exist.
This project is mainly focused on home improvements. It consists of 4 applications using actuators to manipulate the displacement of the product. For a vertical displacement, we will be using a TV lift mechanism. For the second application, there will be a swing door. A sliding drawer will be used as a horizontal displacement, and finally, a single hinge flap design which will consist of a folding window. The modular design will be connected together using T-brackets and a structure made out of 80/20 aluminum extruded bars. It will also have a plywood sheet placed on the bottom surface of the modular design to allow a bolt-on connection point between the support base and the overall system. These support bars will be welded together, and reinforcing the outside columns will improve stability when in motion.
Hello, I'm William Daniels, the computer engineer on this project. To run all the applications that were shown in the design overview, we needed a way to provide power to all the electrical components of the station and control signals to any control components. On the left, we discuss our plans for power distribution to our electronic hardware. We've designed 4 PCBs which will be used to wire up our microcontrollers, sensors, and other electronics, and we plan on using DIN rails to mount our electronics and their wiring to the inside of the system. Our microcontroller PCBs will have Molex connectors so that they can connect to the Stabilis ECU, which is used to control the actuators directly. While the connection to these Stabilis ECUs will be wired, most of the electronics in the station will communicate wirelessly to fulfill the requirements of the project. A tablet attached to the station is used to send command wirelessly over the MQTT protocol to the ESP32 microcontrollers through a Raspberry Pi MQTT broker, which is sort of like a server. These ESP32 microcontrollers can then send these commands to the ECU over UART. A picture of this setup is shown on the upper right. As we discussed last slide, users will be able to use a mobile device to wirelessly interact with the demonstrations and change their running parameters. This mobile device will be running an application that we develop, and a picture of the still in development prototype application can be seen on the upper right. The user can also use RFID fobs, wave to open sensors, and other inputs that are directly connected to the ESP32 microcontrollers in the station to control the applications. Everything we've shown you up to now demonstrates the planning that we've done this semester in Senior Design 1. Next semester, we'll finish up our prototypes of the control system and assemble our PCBs for electronics. We'll also order the parts we need to build our demo system so that we can build and test it. We're still on schedule for refining our prototypes and putting all of the components of our station together by the end of Senior Design 2.